Hello, I've got some questions on upper and lower bounds here to go through. So what we'll do is I'll go through the first few questions and then I'll let you get on with the rest of them. Okay, so first of all, the weight of a bag of potatoes is 25 kilos, correct to the nearest kilo. Write down the smallest possible weight of the bag of potatoes. Right, so if it's rounded to the nearest kilogram, then 25 is going to be in the middle, isn't it? So the smallest it could have been, to be rounded to the nearest kilograms, that's to the nearest whole number, the smallest it could have been to be rounded up to 25 would be 24.5. And the biggest it could have been would have been 25.4999. And go on with those nines for as long as you like, okay? But we have to round that to 25.5. So the smallest possible weight of the bag of potatoes is 24.5 kilos, and the largest possible weight of the bag of potatoes is 25.5 kilos. Okay. Next question. The length of a line is 63 centimetres, correct to the nearest centimetre. Write down the least possible length of the line. So correct to the nearest centimetre means correct to the nearest whole number. So the answer is 63. So if anything bigger than 62.5 was rounded to the nearest whole number, you get 63. As long as it's less than 63.4999, etc. Here we go with the nines again. So the least possible length of the line would be 62.5 centimetres, and the greatest possible length of the line would be 63.5 centimetres. Okay. Right, now let's look here. The length of a field is 340 metres to the nearest metre, and the breadth of the field, or the width of the field, is 117 metres to the nearest metre. Calculate the upper bound for the perimeter of the field. Okay, so what we've got to look at is what perimeter we would get if both 340 and 117 were at their upper bounds, were at their maximum. Okay, so the 340 has been rounded to the nearest metre, so that length could have been between, well, let's look at the lower and upper bounds. So to round to 340 to the nearest whole number, you've got 339.5 and then 340.5. Okay, using the techniques that we looked at in the last couple of questions. So the upper bound for the length of the field is 340.5, and then our 117, the upper bound would be 117.5 realistically, although we do know it would be 0.499999, and keep going with the nines. Okay, so the perimeter of the field, remember, you're going to have two lots of the length and two lots of the width. So we need two lots of 340.5 and we need two lots of 117.5. So that'll be 681 for that calculation and 235 for that one. So when we add them together to get the total perimeter, we get 916. So the answer is 916 metres for the upper bound of the perimeter of the field. And I'm just going to show you one more question. We'll use this one. So the length of the rectangle is 35 centimetres, correct to the nearest centimetre. The width of the rectangle is 26 centimetres, correct to the nearest centimetre. Calculate the upper bound for the area of the rectangle. Write down all the figures on your calculator display. So we can see that this is going to be a calculator question. So we're wanting the upper bound. So the upper bound of the length of the rectangle would be 35.5 because it's to the nearest centimetre. and the upper bound of the width of the rectangle would be 26.5 centimetres to the nearest centimetre. Okay, so when we multiply those two together, because we want the area of the rectangle, so we're doing 35.5 times 26.5, and it says write down all the numbers on your calculator display. So we'll just do that. 35.5 times 26.5 is 940.75. Okay. And we need our units on here. So that would be square centimetres. Okay, so you just bash on with the rest of these questions and give me a shout if there's anything that you're not sure about. Okay, see you soon.